All right. Okay, so now let's look at functions. Functions are very important. What is a function? So if I were to like conceptualize something, a function, right? Let's look at a simple example that would make sense. For example, let's say you you daily you do something, right? So you can say, you know, this is your daily log. Let's say if you're supposed to build a log, okay, right? You can say, wake up, you know, brush my teeth, you know, shower, eat breakfast, get ready, go to work or drive, right? Then you do, I don't know, work at work, your work, and then, you again drive, you come home, when you come home, you eat dinner, okay? And then everything in here may involve a lot of different steps, right? So this is your daily log. Now, if I were to ask you that, give me the, you know, the all the activities that you do during the day, right? A wake up may involve, maybe setting up, clicking the alarm multiple times, going back to sleep, right? It may not be just simply you wake up, brushing may involve, uh, taking a brush out, putting the toothpaste on, doing the cleaning, rinsing, all of these stuff, right? So if I were to, and this thing you repeat daily basis, right? So there are sub steps to everything, right? To everything pretty much, right? Right? Shower also, you turn on the shower, you measure the temperature, you come out, you do whatever you have to do, go back in there when the water is hot, you rinse your body, whatnot, right? So there are multiple steps to this process that I call shower, which you repeat pretty much every single day. You may take different paths, right? Maybe one day you forget to wash your face, right? Or forget one day you don't wash your hair. But some days you do. But there are a lot of steps that are common, right? So you can take those steps that are repeating, and then you can create something called functions, right? And the reason for that is, if I were to print this log every time for the whole day, then you have to literally write everything from scratch. That I get up in the morning, I put on my slippers on, I come out of the bed. I mean, it's a long list of things you do, right? Rather than I would create a function called wake up, and some of the steps are going to be in there because they're repeating. And then I will create a function called brush, which has some sub-steps for brushing, right? And then so on and so forth, right? This way, I can reuse the same steps over and over. And you can modify them as well, right? if you have a brush function, doesn't mean you're always, you can say, if it's a Monday, I'm going to wash my hair. If it's, not Monday, I'm not going to wash my hair, right? But it's a brush function. I mean, it's a shower function. So that's in nutshell what a function really means. Okay. In programming, you can do the same thing that allows you to minimize your code and build this, library of functions that you can utilize to do your things, right? So one of the functions would be, let's say, add function, right? If I want to add two numbers, right? I can write a function that adds it or calculate interest, whatever, right? The function, the way it's defined is you would use a keyword called function, and then you would name this function. So let's say I'm going to name it add. Okay. Again, programming is it's pretty much like, normal life. Everything that you're going to do, it somehow resembles to normal life, right? So it's an add function, and then it's going to have two parentheses. Parentheses is where you can pass stuff that you can customize, right? So for example, instead of add, let's say build a shower, right? And then I can provide which day it is, day of the week, right? Which means if it's a Monday, I only shower. Let's say if I only wash my hair on Monday, right? Then I need that feedback. I need to know which day it is, right? And then I can do that. And then the function body is nothing but a curly brackets. Okay, so there is a function name. Sorry, there is a keyword called function. So you put function always first, then you put a name, and then you put parentheses. There's no gap between the name and the parentheses. And in between, you can pass the I call the argument or parameter, whatever you call it, right? That would change the nature of the function. And inside, then I can say, let's say if it's showering, right? Then I'm obviously, you can't shower in code, but I'm just gonna console log it. So console log, turn on the shower, right? Let's say usually you turn on the shower, wash your hair, wash your body, right? The 3 steps. Console log, wash your hair, and let's say wash your body, right? I'm doing 3 things. I haven't actually used this day of the week yet. In order to call this function, all I'm going to do is use the name and then put the parenthesis. This actually executes the function. Basically, this is the definition of function, and this is the execution of the function. Okay, when I execute it, it prints all 3 statements, whatever I've written. Basically, just just like as if I've written it outside. There's no difference, right? The cool thing about this is now if I were to write these steps, I don't really need to. Let's say if I take shower 5 times, right? Then I don't need to console log this, every time, right? Otherwise, it'll be like a 15 steps, 3 steps, 3 steps, 3 steps, 5 times, right? Instead, I just call this function 5 times, right? And it would print all of these, you see, 15 items, right? So every function execution basically prints this. Again, for the second time, it prints this. So this becomes very easy. If something you're repeating, right, it's similar to like for loop, but in a way it's different, right? Now you can actually provide the day of the week. So you see how in the parentheses you say day of the week. Here I can provide day of the week. So I can say Monday. Okay. I can say Tuesday, Wednesday, right? Thursday and Friday. So for every day, again, I'm just gonna so now if I print this, again, I haven't actually, so a day of the week is nothing but this. You see, there's a function name and I'm passing something. So inside of this function, this day of the day is basically Monday, right? So I've passed Monday into it, and I can make a decision that inside the function say, if it's, remember the if statement we had? I can say if the day of the week equal to Monday, right? You can say don't do anything. Don't do this. Or don't do anything. Else you wash your hair. Right? There's a shorter form as well, but this means that if it's a Monday, then I'm not gonna do this step. Otherwise, I'm gonna do this step. So let me just comment out all the other. Only keep Monday, right? If I run this, it's only gonna print 2. It's gonna say turn on the shower and wash your body. It doesn't say wash your hair, right? That's because I passed Monday here. But instead, if I pass Tuesday and then clear this and run this, I get 3, right? So this day of the week is one parameter that lets me change the routine, right? Because otherwise, if I don't do this, and then it just repeats itself every time, right? Doesn't matter which day it is. It always does this 3 steps. But if I pass this day of the week, it allows me to, customize this. So one day I can do something, the next day I can do something else, right? So this is very powerful. I can provide multiple of these, right? Let's say on also, yeah, instead of doing this way, the best way to do is if it just I can just use else, right? So I can say if this is not equal to Monday, then run this. Then on Monday it doesn't run this, right? This is the other way around, right? So I say if the day of the week is not Monday, then wash your hair. You don't even need to provide else, right? Because this would not execute if it's Monday, right? I'm going to provide two more parameters. Let's say if it's a full moon, right? Then you don't take shower at all. Okay. On full moon, you don't take shower at all. So when I have a full moon, I don't execute any of these steps. Okay. So I'm gonna put this, and then for full moon, what you need to do, just provide yes or no. So if I say yes, I mean true, which means it's a full moon. So it's a Tuesday and it's a full moon, right? If I pass false, which means it's a Tuesday and if it's not full moon. So let's change this function so that on full moon, you don't take shower. You know, some people are superstitious, right? So the exercise for you guys is to take this full moon and then not execute anything. If it's a full moon, don't execute anything, like, which means it doesn't do anything. It doesn't print any of these statements. I'll give you, let's say it's 4:40, give you 5 minutes. So come back at, let's give 10 minutes, right? So you get a little bit more time. And again, this is very important. Once you understand functions, then you are getting into the real coding zone, right? I'll be back in a second. Let me get some water. Yeah, once you have a solution, you can send me to a private chat. It should be pretty much what you've done, with the day of the week, right? You just have to provide an additional. Um, and in order to test it, you can try a combination of it. Like you can pass Tuesday true, Tuesday false, Monday true, Monday false. See what prints. Okay, let's look at the solution. All right, so you can always read, as I said, the programming, it's like, in a way, it's a real language, right, in itself. And you can always read it like this: if day of the week not equal to Monday, do this, right? So before I start, I already know that if it's full moon, so I can say, if I'm just going to write like in a regular language, right? In English, pure English. If it's full moon, don't take shower. In this case, no console logs, right? If it's a full moon. Or you can say, if it's not full moon, then take shower, right? Which means console log, right? So all you have to say, if it's not full moon, then have the console log. Otherwise, don't have console log. That's it. And you can wrap the whole, because remember, washing your hair on Monday, it's only one of the items you're changing, right? You're still taking shower. In this case, if it's a full moon, you're not taking shower at all, right? So yeah, you can wrap this if statement around every single statement. Doesn't make sense, right? Instead, I would just say, if full moon not equal to true, right? Then only you need to do this, right? So if I format this, it looks something like this. So it doesn't matter which day of the week is. If it's a full moon, then it's not going to print anything, right? So if it's Tuesday and true, it's going to take, which means you're going to, oh, sorry, let me remove this stuff here. Which means it's going to print all three, right? What happened? Let me run this again. Okay, it's Tuesday and true. Oh, because it's a full moon, my bad. Which means it's not going to print anything. If it's false, then it will print all three, right? And if it's Monday and false, then it's going to print only two things, right? It's going to skip the washing the head, right? Washing the hair. So that's how you do this, right? Whenever you have multiple step, you can just wrap the whole thing around it. Any question on this one? I think it's your first attempt, so it let us sell down. But functions are very easy to handle. I wanted to give you this example that kind of mimics the real world, right? So you understand it. Okay, but in you usually don't do any kind of like a shower or anything like in the coding, right? You do mathematical operation or you do something else, right? So let's take a different approach now. We can look at the example for so like a math, right? So let's look at a very simple example. We can create a function call add. Remember, it's always a function first, name of the function, then the parenthesis. If it's add function, then what should I pass in? Any idea? What should I pass inside the add function as parameters? What do you usually add? Numbers. Yeah. You can add strings as well, but typically you would add numbers, right? So I can add, I'm just going to say N1 and N2, right? As short form for number one, number two. And then curly brackets, right? Inside, all I'm doing is adding those two numbers, right? Which means I can say total equal to N1 plus N2, right? But this doesn't actually give, yeah, it works. And I can also do console log here, right? Total. But console log is just for debugging. It's not, console log you don't use in real programming, right? It's like to check your things. It's not really um, a real, you don't use, there is no real use for console log in programming. Okay. So you don't usually use this. Instead, what you do is every function has an input, right? Input is basically two numbers, and then it has an output. Because if in mathematics, you have, let's say 1 plus 2 equal to 3, right? Which means the input is 1 and 2, and then equal to, which is an output, is 3, right? So in order to have an output of a function, you have to return the output, which is total, right? What happens in a return? Basically, this function takes this to number and it returns the total. Okay. So previously, remember we called that function called shower, and we didn't do anything, right? Now we are going to call the function with two numbers. So N1 is 1, N2 is 2. And then because it returns it, we can cast the total, right? So we can say total. Actually, here you don't need to do total. You can just return this, right? Because I mean, you could do that, but and then here you can say let total equal to this, and then you can console log to make sure that the total is what you expected, right? So let's run this. Oops, I need to. Right, the answer is 3. So I've created a function, add function, where I can pass any numbers, and then it returns the value, the total, right here. It saves in a total, and then I can just console log. Make sense? It's pretty straightforward. So function takes an argument and it returns the whatever the value, in this case is a total.
I have a question.
Mhm.
In the previous function that we just did when we used console.log, it's just
Yeah.
checking to
Yes.
for the output. And then outside of the function, when we use shower for Monday, can you explain how that works?
Yeah. So let me first copy this, and I'm just gonna go reverse my decisions. Yeah. Okay. So here's an example, right? So in this case, there is no return. Okay. Okay. And I intentionally did not do return because I just wanted to print those things out to show you what the final, what the process is for function, right? So first, so your question was this, right? How?
Okay, so how council log is used in this situation.
Mhm,
If you were to use return there, would
mhm.
it do the same thing, or
No,
what was
no.
the purpose of using
Oh, okay, okay. So
console.log?
return, I would not use like this. What I would do is, because there is not a single item. So if you previous the sum, I have one number, right? Because you can only return one thing. Okay, you can take in 50 things. I can pass 50 different things, but I can only return one thing, right? So what I would do is, in this case, it makes sense to just return everything in an array. So what I would do is I would create an array. So let's call, you know, let process or steps, right? And I'm going to create an empty array. Okay. And then what I would do is, if it's not equal to full moon, then I would say steps. Anyone remember how to add things to an array? I want to add this turn on the shower to the array, the string, right? How do I do that? There are methods, right? That you can add things to an array. Push, yes. Yep, you can do push or splice. That's good. So in this case, you would use push, right? So I would say push, and then I would push this, right? Then if it's a Monday, then I would push the wash the hair, right? And then wash the body. So I'm just going to replace all the console log with push, right? So now what happens is, if it's not a full moon, then it's going to add the shower, turn on the shower in the steps, right? If it's not a full moon and it's not a Monday, then it's going to push this. And if it's not a full moon, then it's going to push this, right? And then at the end of this, at the very end of this, I'm going to return it. So I'm going to say return steps. Okay. Remember, you can only return one thing. So either if you have many things, you just put it in an array and then return it. Or sometimes if there are different kind of things, right? In this case, it's the same thing that you're returning, like bunch of strings. So I can push it in an array. But if you have many different kind of things, right? Then you can push, you can create an object and then you can return it. And then, okay, so the way it works is now, outside, I can say let all steps equal to, and then now I can console log to see what the steps are, right? So okay, it's nothing because it's true here, right? But if I say false, then I would have 2 steps or 3 steps, right? You can see all 3 steps in that order. If it's Monday, then I would see 2 steps, right? 2 steps. So typically this is how you do things. Yeah, because if I had shown you like this, it would be more confusing, right? So that's why I said, just show console log that gives you what's happening, but ultimately the function not always return something. There are functions that doesn't return, they do something, but they don't return anything. But there's an impact of that function, right? Like for example, if I say to turn on the switch, right? Then I turn on the switch, then that's done, right? There's no impact of that, like there's no return. But if I add 2 numbers, I need to return the result, right? So there are functions that don't return anything. There's a function that returns something. So it's up to you to decide. Okay, I'm gonna put this in the chat for everyone to see. You can copy paste somewhere. All right, so let's go back to the other example. To our add function. So I'm just going to rewrite it. Add has number 1, number 2, and you can have many numbers, right? And it returns n1 plus n2, right? And I can call it add 1, 2, and then return. It will return something, and I can save it in a value called total. And then I can print that total, right? See, the console is an interesting thing. In a real, in a programming, there's always some sort of output. So like, console logging is just a one way of showing your output of your application. But imagine if you have a user interface like this is user interface. The output would be, the user interface, like this Captain Anonymous written is using some sort of logic, some function that prints out this here on the screen, right? This button is created using one of these, right? So output is nothing but a button that gets that's shown here. So yeah, functions are my favorite because you would see the power of functions. They do so many things. They make programming much simpler, right? With few lines of code, you can do 50,000 things because of the functions, right? So remember, like in the movies, you would see like somebody executing something, like some secret stuff, right? And they'll like, okay, I'm gonna delete everything and then move the satellite, and I can nuke some country, right? Now, there may be so many different steps, but if that person has to execute every single step one by one, it'll be too many things. There'll be like 3 commands: move the satellite, nuke the country, and then move back the satellite. right? So yeah, and so 3-step, you do everything, but inside you have sub-steps, right? So, okay. Let's do a calculator, interest calculator. I think that's the interest calculator. Let's look at how it works first. We're not gonna look at like a compound interest, just a simple interest. So any interest calculator usually have, some sort of loan, then interest rate, and then monthly, yearly interest. Okay. So usually if I wanna, let's say this is let's say if you took $1,000 loan, right? And then your interest rate, or I'm gonna call it rate, is 5% on that loan. Right? Let's say you have a credit card, the balance is $1,000 and your interest is 5%. The interest you pay, right, is nothing but the loan amount, right? Multiply the rate, divide by 100. This is your calculator, right? So if I just console log interest, and then run this, it would be $50, right? You're yearly paying $50 if you have $1,000 balance and 5% interest rate. You're paying yearly $50. Okay. So I want you to convert this into a function called interest calculator. You decide what the input is going to be, and you decide what the output is going to be. I already gave you the formula, right? Any question before we start? All right. So yeah, so build this interest calculator, and it should have an input and it should have an output, which is an interest. Remember, output is always one, input can be many. All right, be back in a few minutes. Let's take this one should be simpler. So let's get 6 minutes. So we'll be back at like 5:20. Okay, so yeah, this would have been, this is a simpler one, right? Just like an ad. But instead of ad, we have, you know, loan and interest, right? So if I pass the loan and rate, right, inside, and then inside of what I want to do, I need to calculate the interest, right? So let, or I can just simply return it, right? Return the, I can just copy the whole formula. Just like A plus B, this is just doing the interest rate, right? And that's all you need to do. And then you can say let interest equal to interest calculator, and you can pass the loan and the rate, right? And if I console log outside the interest, it should print 50, right? I'm just gonna comment this part, otherwise it interferes. Okay. This is how, so now you don't have to write formulas for this. You can just write, you can just call this, right? And I can just pass anything. I can say, I have $2,000, right? And my rate is, a lot of people have a lot of credit card debt, right? So let's say if you have $10,000 in debt, credit card, and let's say usually credit card rates are like nowadays like 15, 16%, right? Let's say how much money you pay. You're paying $1,600 per year just to have this balance. It's a lot of money. That's why I always say in America, the whole system is designed to make poor people poorer, right? And this is the evidence of that. If I have a $10,000 and if I'm paying 1,600 just to have that balance, that's a lot of money, right? Okay, so now you got the gist of it, right? You have a function with the argument, and it returns something, right? Let's look at a little bit more complex functions. Uh, hmm. Let me give you something else. Let's have a profile. And age is, let's say, 20, right? So what I want you to do is I would pass this profile into this. I'm going to create a function called get age. Get age. Okay. I'm going to give you a structure of this function. So you'll pass the, I'm going to call the, yeah, I'll just call it you passing the profile in here. And then it returns the age of the profile. Okay. So in the end, I would have this. You can say let age equal to get age, and then I would pass profile, right? So this should print 20. Let's try this. You already know how to do this, right? You just have to put it inside a function. That's it. And return it. Let's do it quickly, right? You already know how to do this. I mean, you already know how to get the age from the profile, right? It just, in this case, we're just using get age function to do that. You pass the profile and then you get it, right? So let me give you 4 minutes. This is easy. You should be able to. Okay. So any ideas? So here, do the same thing. You know, you have a profile. So all you have to say return profile.age. That's it. Right? So get a profile and you just return profile.age. So if I run this, I should get 20. Oh, I have to console log this, obviously. Yeah, I get 20. Okay. So now instead of calling the object in this, I'm just going to use this function to get that age, right? You must be wondering, why can't I just call this, right? Yeah, you can call this. This is a simple example, but you know, you can do a lot more with it, right? Um, let's say if you have a different situation where you can say, um, you know, bank, I'm going to call it bank rate. And then let's say I can have a loan of, say, $1,000 and rate of, let's say, 5%, right? Then if I want to get, let's say, get interest, right? I would pass the bank rate, the object inside, and then inside, all I have to do is remember the formula, right? The formula is loan multiplied by rate divided by 100. So in this case, I would say bank rate dot loan multiply by bank rate dot rate divided by 100. Right? It's the same thing. So now I pass the bank rate object, which has all the properties. Instead of passing, let's say, loan and rate, I'm just passing the object, which has all the property. So I can get the loan from this bank rate using this dot operator. I can get the rate using the dot operator, and I can divide it. Right? So this is pretty simple, and I get 50, right? So functions are very useful. Now we are mixing the functions and objects and everything else, right? But it's the same, the concept is the same, right? If you learn, because you learn how to access the objects, you learn how to run function, you just mix them together, right? Oftentimes in programming, a lot of people kind of get stuck on, like, how do I do this, right? Instead, just do this by whatever comes in your head first. Because a lot of people are afraid, what if this fails? Okay, if it fails, nothing works, right? But if it doesn't fail, then something would work. So try that, right? You will learn something, and then, you know, uh, you would progress. So that's how I see it. Okay. Um, let's take a little different example. Let's get it. This one is a little bit complex, but it will give you some some idea of how these functions are so powerful. Okay. So let's have another function where I can pass bunch of numbers, Okay, so let's say, let's just pass in an array. Let nums equal to 1, 3, 7, 2, 4. Okay, I want to find the biggest number in here. You know what? Yeah, let's find the biggest number. I think that's better. I want to find the biggest number in here. How do I find the biggest number? So the function would be find biggest. Okay. It's easy to say find max, right? The argument is going to be, let's say, nums. Okay. So what is the return is going to be? Anyone? What would be the return? I'm trying to find a max number in this array. What would be the return? It could be an index of 7 or 7 itself, right? In this case, because we are saying max, we want to just return the number itself, right? So we can say 7 is the max. Okay. Think of this way. You have, it's a bunch of students standing in the line. Okay. I'm just going to take that metaphor rather. A bunch of students with varying heights. It's a long line, right? Usually if you like 2 or 3 students, you can see their height and you know who is the tallest, right? But this is a long line, which means you can't really tell who's the tallest, but you have a measurement. You have what is it called? The tape, measuring tape, right? Where you can easily measure that person and then define that tape. I mean, the height, and then compare. How do you find the biggest person, tallest person in that line? Anyone? What's the right method? Forget about coding. You're just doing it manually. How do you know who's the tallest person in that line? Right? Yeah, you can measure the first person. Let's say first person is 5 feet. Okay. The next person is 5.1 feet. The next person is 4 feet. The next person is 6.5 feet, right? You have all a bunch of, you can measure it, right? But how do you know who is the tallest in that, right? What's the method? Let's say if you have 1,000 of such numbers, right? Once you visit all of the numbers, your job is to say, who is the tallest person in the line? How would you figure it out? Are you going to write all the numbers down in some paper and then go home and check? How are you going to do that? Let's say you have let's say one way to do it is, you write all of them down, right? But let's say you have too many of them. How do you find who's the tallest? Anyone? Compare each number to other. That's a good one. The only thing is, how do you compare? Let's say if I have 1,000 people, right? If I have to compare each number with others, I have to say, okay, this is 5. Is this the tallest? So I'm just going to find, oh no, this is not the tallest because there's the bigger one number, right? And then I have to say, oh, I'm going to take this number. Now, is this the tallest? I'm going to have to check with every other number. So one algorithm would be, I go and write everyone. I don't do anything. I just measure, write down in the paper, right? And I get a list of items, list of numbers, right? And then I just say, okay, I take, say, is 5, if is 5 the tallest? If I find something taller than, bigger than 5, then he's not the tallest, right? Then I take the second number. I'll try to do the same thing, but it's really cumbersome, right? The best approach is you take a number, you can say, assume the first person is the tallest, okay? So let's say these are all the heights. So I'm gonna say the first person is the tallest. So 1 is the tallest. Is he tall? Is the tallest? Yeah, in the number that I examined so far, he is the tallest, right? Because I only examined one number. Then I would look at the next number. Okay, is my previously tallest number, is the next number bigger than that? Yes. Then I'm gonna say now the 3 is the tallest, right? Then I'm gonna check, compare with the 7. Is 7 taller than 3? Yes. So 7 is the tallest person. Then I look at 2. Is 2 taller than? No, not. Is 4 taller than? So 7 is the tallest number, right? So you just need one number. You don't even need to write them down. You just compare them as you go along. You just keep one height that is so far the tallest. At the end of the whole thing, you will have that one number, right? So we're gonna do the same thing in here, right? And this is called algorithm. That's how computer works. So if computer gets, let's say, millions of numbers, it needs to find the biggest number. It just have to visit everyone once, right? It doesn't have to compare everyone with others, right? Because that would be too much. So how would it do that? So what I would do here is I would say, let the first number. Who is the first number here in this? Where do I find the first number in this array? Anyone? 0th index, right? So the first number is the 0th index. So I can safely say that max equal to nums 0, right? I got my tallest person. The first person is the tallest person so far, right? Then I would loop through the numbers. So remember we learned about looping. There are 2 different types of loops. One is for loops, basically. One is you have to do for 0 to something, and then I++, remember that method? Or you can do another for loop where you can say value of nums, right? You can do this way as well. Okay. So you get each value one by one. Okay. So this also includes the first one, but don't worry about it. You're just going to compare the first one with the first one. It's not a big deal. So you're going to say if the value, which is which could be the second one or the third one, doesn't matter. If the value is greater than max, right, then max is the value. Okay, it's a simple logic. I take the very first number as the max, right? Then I go through one by one. For loop lets me go through one by one. So let's see how it works. So first it would give me the first number, which is 1. So this would be what? My max is going to be right now. My max is what? I'm just going to put it here. My max is right now initially 1, right? Then I'm going to go one by one. I'm going to say, is the new value, is it greater than max? So it compares this two. So it compares from 1 with 1. No, it's not greater than. So it's not even going to go in here. Then it takes a second number. Is 3 greater than max? Yes. So now max is 3. Then it's going to say, is 7 greater than max? Then the max is 7. Is 2 greater than 7? No. Is 4 greater than 7? No. So the max remains 7, right? So all you have to do is return the max. So welcome to the real programming. And if I console log the find max and then pass the nums inside, you will get 7. Right? If I add, let's say 30 here, right? Which is bigger than everyone else. And if I run this again, I would get 30 automatically. It always finds the max. So this is the trick, right? I explained to you. You go one by one. Are you bigger than what I have? Yes. Then I'm going to take you as the biggest person. You can actually take that person from the line. You go one by one. You take the first person out of the line. Okay, then you compare with the first with the, because you can only compare 2, right? You cannot compare more than 2. It doesn't make sense. So you take the first person out of the line, and then you compare with the second person, and you can just look at. You don't even need a measuring tape, right? You just look at them and say, okay, okay, the second looks like the second guy is the tallest, right? Then you tell the first guy, just go back to your line. You bring the second guy out because he's now the max. Now you compare him with the third one, right? And then ultimately the guy who is with you is the tallest guy that you're comparing with other, right? As soon as you find the tallest guy, you replace that. So that's all it is, replacing logic. See, it's a so simple logic that actually finds the maximum number. Let me just paste this logic, right? So this function, so beautiful. It provides you, this very complex mechanism, and it makes it very simple, right? I would like you to think about this algorithm. And the reason I always switch a little bit, class to class. Last year I did not teach this, but if you want to be a programmer who solve complex problems, daily life, right? You have to know this kind of stuff, right? And it's not a rocket science. When I started, I did not know this. Somebody has to teach you this kind of stuff, right? Once you learn that, then it becomes a second nature, right? And once it becomes second nature, like I don't have this written down somewhere. I just write as I think. Okay. So yeah, this is how it works. It's a lot of things are magical, and these are called algorithms. If you want to know more about it, there are some algorithms that are really amazing. This is called searching algorithm, right? I'm searching for something. right? Let me give you another taste. What if I want to sort this? Now this becomes very difficult. I want them. This is a line with a bunch of people. I want them in a line such that the shortest person always on the front and the tallest person always in the back, right? So this would be 1, 2, 4, 7, and 30. How would you achieve that? Don't think in terms of programming. Just think in terms of how would you do this. If you can remember, all the algorithm that you can do in the programming, you can do in the real life, right? And that's the best way to deal with this. How would you achieve it? And there are many different ways to do this, not only one way. Any ideas? How do you sort them? Just think of, yeah, small to big. Yeah, from small to big. So a simplest algorithm is I already know how to find the max, right? So I can say, hey, find the max of this guy, remove that guy from the line, right? And then, or I can I can write an algorithm called find min, right? This way, first time I run it, I would get 1, right? Because that's the smallest person. Then I find the next min, and I would push it into another array, 2. Then I find another min, which is 4, find another min, 7, and then 30. But every time I find something, I need to remove that person from the line, right? Then only. So I would have a line. I would just go through every number, every person, find the smallest person in the line. I would say, okay, now you create a new line, right? Then from the rest, I'll find the second smallest, right? Second smallest in the smallest, right? Because I took the smallest person out. Then I would, this way. The only problem is I have to visit what if so if it's like a 1, 2, 3, 4, 5, if it's only 5 people in the line, I would have to then go through the entire line 5 different times, right? Because every time I go through it, I find the smallest person. So if I have 5 people, I have to go through in that line 5 times. And that's not really efficient, right? What if I have 1 million people to sort? Okay. Can I go through 1 million times? That's not really not efficient, right? So small, if I have like 5 people, I have to take 25 times, like 5 times, right? Which means I will have to examine 25, not exactly 25 because every time you're removing them, right? But approximately, if you go to if you have 5 elements, you go through 5 times, you are actually examining 25 people, right? If I have 1 million people, then you go through 1 million times, million. So million multiplied by million. Okay. That's just an astronomical number. Okay. What is 1 million multiplied by 1 million? Somebody, 1 trillion. Okay. So yeah. So if I have 1 million numbers, I have to compare trillion different times, right? It's not very efficient. So what is the other way if I want to sort it? And that's called brute force, right? If I remove every person one time, that's brute force. There are other ways to do this. Okay, one would be, I can break this into two, right? Sort them, right? And then you can do that way. So break the whole thing into two, sort them, keep breaking it until you get like smallest, like two people, right? And then sort them and then reverse them, right? So there are a lot of different algorithms, but I just want you to think in that term, right? Whenever you solve a problem, it's a problem that is of a, relate to a real life problem, and try to solve that problem in a real life. And and then implement that, in programming. Okay. Um, there's actually, let me see, there's actually an interesting sorting algorithm animations. It's pretty interesting. Okay, so this is called insertion sort. I'm gonna play this. See how they're sorting it. This is called selection sort. See, it's actually arranging stuff, right? And there are 4 different algorithms. There's a bubble sort. This, just look at this one. This is the random number. Some of the data sets are already sorted. The fast one is called quick sort. But the one I was talking about, the merge sort, which actually breaks things, is this one. Notice this one. You see, it divides everything into 2 and then sorts them. This is called a quick sort. This is the fastest. And these are different kind of stuff. Like, let's say if you already have a sorted, if I refresh it, if you already have like already data, your data is almost like half sorted, right? Which means this is random data, which means you may have like a smaller, bigger, smaller mix. This is like a reverse, which means it's already sorted, but in a reverse order, right? So yeah, and it applies the same techniques to see how. See, if it's a neatly sorted, it's so fast. If I just simply, okay, let's just go again. This is neatly sorted, right? Which means it's almost there. Then this algorithm is really quick. This one, even though it's neatly sorted, it takes, this compares everything to everything. You see how slow this is, right? This also, yeah, this is also fast in that sense. And this is the, even though this is the fastest, but it depends on the data as well, right? We want the best algorithm to be on the data. But anyway, there are lots of different algorithms. If if you want to read it, if you're interested, if you want to become a really good programmer, you can, you can find this kind of stuff, on a spare time and then just do something, right, with it. If you go for like a, like interviews, they would most probably ask you a problem like this. Say, okay, I have an array with a bunch of numbers. Find me the maximum number. And you have to explain the algorithm, why this is the best, right? So yeah, let me give you this code. something interesting to do, right? And hopefully you like it and use it. We're not going to do anything complex like this, but it's something to trigger your trigger your brain into thinking, oh, how do we do this, right? So so yeah, functions, we are like halfway with the functions. There are some other functions that we're going to explore that are very useful. And then after that, we may look at few other things, but that's the end of JavaScript, right? At least some basic JavaScript that we need to, to build games. And then we're going to focus on something called React, where actually we will build something very useful. We don't have to do console logs after that, right? So, and it's actually much simpler than what what we learned so far, because it's a unique language that where you actually build games and stuff like that, right? Let me give you a quick example. Let's say React code sandbox. Okay, so this is a React app. Let me give you something more complex. React game. Not React games. Let's take Snake game. Let's see what you can build with this thing. Okay. So this is called Snake game. Hopefully it works. I don't know, because you see, this is built in JavaScript. If you can do something like this in this in this class, that would be fantastic. I don't expect this, to build this kind of game, though I remember one student had built it, and it was pretty fantastic. It is possible. A lot of other games are, I don't know what an XOXO game is. Let's see. Yeah, this looks like I don't know what this is. Let's look at the tic-tac-toe. Right? A lot of people play tic-tac-toe. We can build tic-tac-toe. Okay, you can start the game and then, build a tic-tac-toe. Right? So think about what kind of game you want to build, and we can discuss, we are learning all of this stuff, so ultimately we can produce something. I think you all can build tic-tac-toe. It's not that complex game. You can also build something called what is the other game? A lot of people just do, guess the number game. Okay, where you just guess a number. Let's say I guessed 12 and it says try again. It's not very helpful. But typically what happens, it'll say, oh, you're higher or lower, and then you go adjust, right? Something like that. So you can build something simple like that as well. I mean, like this it's like 34 line of code. Actually, it's not bad. So once you learn React, you will use like, the loops, pretty much all like functions, loops, and if else statements, pretty much, right? So yeah, just think about it. I think we are 5 minutes over, but I just gave you a preview of what you can do, right? So think about what you want to do. You may not have a clear idea right now, but you know, soon. But this is, you know, you would be able to do this. I guarantee you. Okay, and that's why I wanted to show you, like, what we are doing is like grunt work and trying to figure out, how this works. Once you know that, you can go and apply this in building this game. And this is only this is only like 33 lines of code. That's your final project if you want it to be, right? So yeah, but you can do multiple projects. You do something simple, and if you finish it early, you can do something a little bit more. But yeah, it'll be fun. Okay, so that's it, folks. I will see you guys next week.